Welcome to This Explainer. Today we're diving into something that's honestly a pretty fascinating evolutionary journey. We aren't just going to sit here and go through a dry, technical lesson on computers. We're actually going to explore the story of how organizations manage their absolute most vital asset, their data. From the messy, chaotic beginnings of early computing to the highly streamlined, intelligent systems of tomorrow, we'll see exactly how the technology we rely on every single day was forced to evolve.
All right, so here's our roadmap for today. First, data versus information. Second, the traditional file system. Third, a deep dive on flaws. Fourth, the database solution. And finally, entering Industry 4.0.
Section 1. Data versus information. Understanding the basics.
So, to really wrap our heads around databases, we got to make sure we aren't mixing up two concepts that, well, people mix them up all the time. Let's start with data. Think of data as your raw material. These are simply collected facts about a specific topic or item. By their very nature, they're raw. They're unorganized and completely unstructured. On their own, these little isolated facts, they don't tell us a complete story or give us any real actionable insight. They're basically just scattered building blocks waiting to be used.
Now, contrast that with information. Information is the finished product. It's what you get when you actually put that raw, unstructured data to work. You combine it, compare it, run calculations on it, and interpret it. It's only when data is processed and organized in this specific way that it suddenly clicks and becomes truly meaningful and useful to an organization.
And you can really visualize this processing stage as a literal funnel. It takes all those chaotic ones and zeros, those raw, messy numbers, and filters them down, structuring them into a polished output. That output, the information, is the exact thing an organization actually relies on to make critical decisions.
Let's look at a practical example to make this super concrete. On the top there, you've got raw data. It's just a jumble of text, right? Stuff like Ahmed Sohar 16J45871 mixed with random phone numbers and names. It's incredibly difficult to read, let alone use. But check out the bottom. Once that exact same raw text is processed and slotted into distinct, readable columns like student ID, name, address, and phone number, bam! It instantly transforms into highly useful information. You can immediately spot exactly what you're looking for.
Section 2. The traditional file system, before modern databases.
Okay, so now that we know what we're actually trying to organize, let's get into the conflict of our story. Before modern tech, how are organizations storing all this stuff? Well, early on, they used traditional file systems, which honestly seemed like a great idea at the time. They were wonderfully simple to use, way less complex to build, and required minimal financial investment up front. You didn't even need a specialist to run the things. But as companies scaled up, this system became a total nightmare for large firms. The disadvantages piled up fast. We're talking massive data redundancy, severe data inconsistency, glaring security problems, and extremely limited sharing capabilities.
Section 3. Deep dive on flaws. Traditional system issues.
We really need to dive a bit deeper here to see exactly why these disadvantages absolutely paralyzed growing organizations. One of the most crippling issues? Something called high program data dependency. Think about how heavy a burden this is. In a traditional file system, the applications used to read the files were directly hard-coded to the physical structure of the files themselves. So if you made just one tiny structural tweak to a data file, like, say, extending the length of a zip code field, you couldn't just hit save. No way. You were forced to go back and completely rewrite every single application program that touched that file. Literally every single one. It was just an incredibly inefficient, time-sucking process.
Another massive headache was concurrent access anomalies. Obviously, in any business, you've got multiple users needing access to the same records at the exact same time. But traditional files, they just couldn't handle it. When one person or application opened a file, that file was locked. I mean, imagine the sheer frustration. Two employees urgently need to update a client record, but the system completely locks one of them out until the other guy is finished. It dragged productivity to a grinding halt.
On top of all that, these traditional systems suffered from terrifyingly poor security and a total lack of automatic backups. Because management had basically zero control over the data, tracking who was accessing or sharing information was next to impossible. You might not even know who changed a crucial file, and heaven forbid the system crashed because there were no automatic backup and recovery processes to save you. Organizations were just left completely vulnerable to data loss.
So, think about all of these crippling flaws for a second. You've got rigid files,
Locked out users, massive security blind spots, and this constant looming threat of permanent data loss. The million-dollar question is, how do organizations actually fix this mess? Section 4. The database solution. Centralized and organized. Well, the hero of our story is the modern database. Unlike those chaotic, isolated files of the past, a database is fundamentally different. By definition, it's a shared, sophisticated collection of related data. It's specifically engineered to support the complex activities of an organization and tailor-made to meet its precise information needs. It completely eradicates the inconsistencies, the dependency issues, and the locked files of the past simply by centralizing everything in a highly intelligent way. And you can really see here how the database engine acts as this powerful central hub. All that scattered raw data enters the system. Stuff like 312 graduates, basic student test scores, or raw budget numbers from previous years. The central database takes all of it, processes it, organizes it, and secures it. And what comes out the other side? Vital, cohesive organizational information. We're talking next year's budget projections, school regulatory data, or overall class averages. The chaos is perfectly tamed.
Section 5. Entering Industry 4.0. Future Trends.
All right, now that we've solved the technological problems of the past with the modern database, let's look out at the horizon to see where this is all taking us next. Have you heard of Industry 4.0? It isn't just a buzzword. It refers to a whole new phase in the Industrial Revolution that focuses heavily on interconnectivity, automation, machine learning, and real-time data. And here's the thing, none of these futuristic concepts are even remotely possible without advanced, incredibly secure, and blazing fast databases acting as the absolute backbone. Modern databases really are the engines making this automated, interconnected future a reality.
As we wrap up this explainer, I want to leave you with a final, slightly provocative thought. We've seen how databases evolved from these simple, deeply frustrating file systems into the sophisticated engines driving today's technology. But as massive streams of real-time data continue to fuel Industry 4.0 and beyond, how will the databases of tomorrow evolve to keep up? I mean, the limitless potential of data management is constantly expanding, and the next big evolutionary leap might literally be right around the corner. Thanks so much for exploring this fascinating journey with me today.